now we need to define when we say the linear set of solutions or the linear combination of the solutions of the differential equation to be linear dependent or linearly independent. So it's rather simple, because whenever we have the linear combination, and such that if the coefficients, if the coefficient that or the constant that are multiplied with the functions of x are not zero, or if all the ci's where I goes from 1 to n are not zero, then it means it is a linearly dependent, or a linearly dependent set of the equations or the set of solutions. But if these all are zero, then we say these are linearly independent solutions. So let's see some of the examples how to find are the solutions of these differential equations are linearly dependent or independent. So this is the first question. It says that determine whether the given functions are linearly dependent or independent. If they are linearly dependent, find the linear relations among them. So for example, we have some functions here, f1t, f2t, and f3t. Now as I have already told you, to find the Wronskian, we have to put these functions in the first row of the matrix. Then after, the consecutive derivatives would be on the other rows. As a result, if this Wronskian is 0, it means it is linearly independent, and if it is not equals to 0, it means it is linearly dependent. Now it is 0, so it is linearly dependent. So sorry, I think I have said if the Wronskian is 0, then it is linearly independent, but it's wrong. If the Wronskian is not equals to 0, then it is linearly independent. I'm so sorry for that mistake. So if the Wronskian is 0, it means it's linearly dependent. All right, so so we can see that it is equals to 0, so it is linearly dependent. So linearly dependent means we can linearly dependent means ci, where I goes from 1 to n, all are not equals to 0. It means we can find the solutions. If they are all 0, then all the solutions of this differential equation which is formed by these functions would only have a solution that is equals to 0. It means only have a trivial solution. So if Wronskian is equals to 0, it means it's linearly dependent. So linearly dependent means there exists some solution such that c of ci, where I goes from 1 to n, are not all consecutively 0. So so here, as we can see, it is equals to 0. So what we did is we multiplied this function f1 with c1, f2 with c2, and f3 with c3. Then we introduce some of the coefficients here with all 0. Then I equate this consecutive term. Then we find this linear relation. So this is how we find the linear relation among them. Okay, now again we have the functions this, exponential t, exponential negative t, and exponential minus of double t are 2 times t are solutions of the differential equation. This so here we have given the solution, given the differential equation, and we have to find the Wronskian, and we have to determine whether they are linearly independent or dependent. So first of all, we have to find the solution of it, because in the previous question we have been given with the solutions, but here we have to find the solutions. So for solving this equation, we first of all write the characteristic equation of this differential equation. So generally this characteristic equation is formed when we suppose that the one solution of it is e to the power r of t. Then differentiation of it would give us r squared simultaneously or to the Rn of e to the power t. Then we take the characteristic equation, which is generally a quadratic equation, sorry, not a quadratic equation but a polynomial equation. Then we find the value of r, and for the different values of r we have already learned that in the previous classes. We find the solution. Now here we can see the first solution is y1 is equals to et, y2 is equal to e to the power minus t, and y3 is equal to e to the power minus 2t. It means these solutions are actually the solutions of it, this differential equation. So we put it in the Wronskian determinant, and we find that it is not equals to 0. So if it is not equals to 0, it means it is a linearly independent case. So it means all constant. If you multiply these y1, y2 and y3 with c1, c2, c3 and form a linear combination, then it is linearly independent, means the c1, c2, c3 will all be 0 simultaneously, and as a result of that there will be only the trivial solution for the linear relation. So we do not need to find any kind of linear relationship between the different solutions of it. So that was it for today.